Hello everyone. Today we'll be learning everything about parallel connections of resistance. What is parallel connections and how if we join two resistance then we will call them parallel. Just like I have given you two resistance R1 and another one is R2. If you want to join them in parallel, your work is that you just take the first starting points and join them at a single point. You take their ending points, also join them to the another point. Then you connect them in the circuit. Any combination of resistance done by this is called parallel connections. This is a basic parallel connection circuit with two resistance. You can also join like this more number of resistance here. Might be 3, 4 like this. That is a parallel connection with three resistance done here, and similarly they can be joined in a circuit. Clear? So I hope you have understood how parallel connections are made. They are very different from series connections, so their values are also calculated in a different way. The way of measuring the combination is that if I am combining two resistance R1 and R2 and the total value is R, then the formula is 1 by R equals to 1 by R1 plus 1 by R2. If I am joining 3, then my net value is 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? Let's solve with some examples. Just like if I am giving you a combination of resistance of like this. The first resistance you join in circuit is 10 ohms and the second resistance you join is also 10 ohms. So you got this one as R1 and the next one as R2. So simply put in the formula 1 by R equals to 1 by R1 plus 1 by R2. That is 1 by 10 plus 1 by 10, that is 2 by 10 equals to 1 by 5. So what did I get? 1 by R equals to 1 by 5. Now just very easily R equals to 5 ohms. Clear? This is how we basically calculate the value of resistance connected in parallel combinations. We just calculate using this formula, we get the value of 1 by R, then just inverting the fraction, we get their actual values. Clear? Let's solve one more kind of this. Just like if in these three connections of resistance, if I am giving R1 is 6 ohms, R2 is 4 ohms and R3 is 2 ohms. What should be the value? Now the formula is known, 1 by R equals to 1 by R1, 1 by R2 plus 1 by R3. So if I just calculate it, then 1 by R equals to R1 is 6. So 1 by 6 plus 1 by 4 for R2 and 1 by 2 for R3. The LCM, what's the value of LCM? The value of LCM is 12. It is 2 plus 3 plus 6. So it is 11 by 12. That is 1 by R. So what is R? R equals to 12 by 11 ohms. So the value can be different. The value can come in fraction. The value can come as a whole number. It doesn't matter. This is the formula. This is how we will solve it further. Now let's discuss some properties of parallel combination. Few properties of parallel combinations are like this. that when you are connecting a circuit in parallel combination, this is a circuit diagram I have drawn. You can see that's a battery with potential difference V and current flow is I. Now the I current flow comes out here. Then when the current flow I appears here, you can see it is getting divided into three portions. The current flow is divided into three parts here. If these resistors are named as R1, R2 and R3, if I just name these channels 1, 2 and 3, current flow basically difference into I1, I2 and I3. They get separated, they get divided into three parts. So the I current flow basically gets divided into three parts like this: I1, I2 and I3. Then each and every part is getting different amount of current flows. After the current flow comes out, they again joins and comes out like I. But for the time being, when they are passing through resistance, each and every resistance is getting a different amount of current flow, which was very different from the series connections. In series connections, we have seen that the current flow through each resistance is equal, but in parallel combinations, the current flow is different for each case. So the first thing we can write about them is that current flows through each resistance is different. Clear? Current flow through each resistance is different, but they are in series connection. The potential difference was different, but here the potential difference is same for all resistors. The potential difference is same, mean between this point and this point, all these three resistances are connected. All of them stays under equal potential difference. That means if V is 100 volts, then R1 is also under 100 volt, R2 is also under 100 volt and R3 is also under 100 volt potential difference, though they are getting different amount of current flows. So you can calculate further equations from here. We got that each of them are having equal potential difference but different currents flow. So see that V is same for all. Then for the first resistance, current flow is I1, resistance is R1. Then first resistance R1, I can write V equals to I1 R1. For the second resistance R2, V equals to I2 R2. And for the third resistance R3, current flow is I3 and resistance is R3. So I here like I3 into R3. For the third resistance, V equals to I3 R3. From here what can I do? I can calculate the current flow through each. You can see if V equals to I1 into R1, then I1 equals to V by R1. Then I2 equals to V by R2 and I3 is V by R3. So we can see how much current is flowing through each and every portion can be easily calculated. Okay, so I1, I2 and I3, these all three values are calculated. Now you can see the current flow totally was I, which was divided into I1, I2 and I3. So if I just add these three, I will get I again. Means what? If I have 10 ampere which got divided into 3, 2 and 5. 3 ampere, 2 ampere and 5 ampere. If I add these 3 plus 2 plus 5 is again 10 ampere, the total current flow, which I am going to do the same. That I is actually I1 plus I2 plus I3. For the value of I, we know from Ohm's law that V equals to IR. So I equals to V by R I can write, where R is the total resistance, and I1 is V by R1, I2 is V by R2, and I3 is V by R3. From all these three, you can see V I can take as common. Why? Now because V is same for all, and also in the equation it is happening same. So V common is 1 by R1 plus 1 by R2 plus 1 by R3, and here I get V by R. So on the both side I can easily cancel V. So what is the final equation I get is that 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation of parallel combinations. This is how we actually derive it. So you can see if I had more than this, I would be calculating just the same way. Now just think like the previous, if I have combined multiple number of resistance in parallel, means I have combined n number of resistance, that is each and every has a value of R, a huge number of resistance I have combined, but all of them values are equals to R. Then what should I get? I know that 1 by R parallel equals to 1 by R plus 1 by R plus so on by n number of resistance should be added like this. So if I have n number of resistance, then I should get n by R as the total parallel resistance. So RP, that is a net parallel resistance, should be R by N. That means the value of resistance divided by N, the number. This formula is very important, which we will see in the next video, where we will see how to solve numericals of series connections and parallel connections. Till then, please go through it and remember this formula very importantly. Thank you everyone.